Hello and welcome back to Compiler Programming. Before we start for today, I want to point you to the GitHub repository for this project. I will link it in the description so you can go and check out the code and any of the issues that are here. I've also marked some of the issues with possible video label, and if you're interested in this particular issue, you can go inside and click on this nice smiley face and upvote it if that's something that appeals to you. And I will consider these upvotes when deciding which video to do. For today, I'm gonna focus on these issues. All constant declarations need to be lazy that we discovered in the last video connected to compiler time execution. To recap, whenever we have a constant declaration, right now only functions are considered lazy and anything else is evaluated right away, which means that we will have problems whenever things are out of order. So let's maybe make that test, or rather I will just go and change our compile test maybe to be that way. So right now we are so here we have status code, which is a constant, but we are calling the answer function that gives us 40, and we are adding 2 to it. Because the answer function is above, everything is fine, but that will not necessarily be the case if we try to move it below. So let's try to do that and see what it will do to our test. We basically are exploding, so let's open up debugger and see what's going on. But the basics of it is that status code cannot find the right function, right? It cannot find the answer. It was not declared above in the scope, and because we are going top to bottom, this is the consequence. Ideally, what should happen is we parse all top level definitions. We completely ignore what is on the right side of them for now and just store it somewhere inside of the special scope entry. And whenever we try to access that scope entry, we will actually go in and resolve. And that would mean that all of it will be parsed, but none of it will actually be sort of processed. Then the outer program will try to get the main function. The main function will start parsing its body. It will get to exit process call. So it will look up this thing, which will force this definition. Then it will look up status code, which will cause this to be evaluated, and then this will cause this to be evaluated. But because all of them will be defined by the time we try to get to main, everything should work out as expected. Now, originally, functions were lazy, were the only lazy thing because I didn't have a concept of a statement, so everything was sort of one gigantic expression. But now we have statements that are terminated with either a new line or a semicolon, and that means that we could just take this left-hand side of the constant definition and stash everything to the right of it and say that this is the lazy part, and it will be evaluated in the first time we actually try to get that value inside of the function. So that's the job for today. Maybe we don't even need the debugger for now, because this is what we will be trying to do. Now, I think we also will need to have the header file for the source H. Yes, we have scope entry type, and scope entry type is either lazy or non-lazy. So entry itself actually already has the right setup for us. And that means that only this thing is not correct. Right, so token type, lazy function definition. So what is the lazy function definition? It is it just has a bunch of tokens, but really I don't think we need this. It should be perfectly fine um, to just get rid of it, I think. So for now, let's just comment this out and we will see what breaks and go from there. Okay. Having a bunch of errors here. Force lazy function definition, that is no longer a thing. What do we have here? Here we have the call to force lazy function definition. Again, that is not a thing anymore. Rewrite function pattern callback. That is kind of interesting. I had this whole setup where I was thinking of having more abstract definition of functions, but that is probably not the right way to go, so we will also change how this works. So for now, let's just token rewrite pattern. Yeah, this all needs to change, I guess. Maybe we will take this one and just turn it into a more standard definition of what we have. So for now, I'll just say return false, and we will just panic. Fix me. Okay, who's next? Okay, token rewrite constant definition. So this is the interesting part. We have scope define lazy, and now that's gonna be our main thing, but currently define lazy also gives the value, while I think even my idea originally was that it will just have an array of tokens as its sort of value, for the lack of a better word. So that's what we are going to do. Right, we have this a right hand side, so maybe we explicitly call this scope entry type lazy constant expression. That would be more appropriate to what we're trying to do. Okay, then we will not do this stuff over here. So we have right hand side, but we will not force it. Instead, we will just make this lazy definition. Scope define lazy, scope name source, and token, no, and right hand side. So this will fail because define lazy does not expect this stuff. Yeah, this is kind of stupid, to be honest. Should accept tokens. I hope that doesn't break anything else. Lazy constant expression. Dynamic array push, entry, tokens, token, no. that is not required anymore. Um, I think. Oh, I guess now I'm trying to. I'm remembering why it was done the way it was done. So the way it was working is that it was creating an array of token values for specifically for overloaded functions. But might be better if instead we allow overloads sort of on a scope level. So any name can map to multiple entries, and whether something is allowed to be overloaded or not would be judged by something else. If that is the case, then it might be that we need to do that refactoring first. So this happens to me quite a bit, that I try to go in one way and then realize, okay, that is not necessarily the best way to go, or I come up with refactoring that would be not so great to do inside of the current thing. So let's just stash whatever we have, verify that we can still build, and start with that refactoring first. So first of all, right now, laziness is attached to the overloads, and we need to get rid of that. How do we do it? Well, I guess inside of the scope, we would do the following. Scope make I'm just thinking, should I make an array of scope entries or a linked list of scope entries? Doesn't really matter, I guess. Maybe array is easier to do. So scope. We have scope map, which is a map to scope entry. And now instead of that, what I will do is I will say that we have array of scope entries, and scope will be a map to that array. Okay, what will that do? Well, it's basically this logic. We can say void scope define internal, because there will be the same logic for checking if there is already an array or not for both defining lazy and non-lazy values. So that's not something that we should do there. Scope define internal, it will get scope pointer. Of course, we'll get the name, and it needs to get scope entry. Okay, if it doesn't have a scope name, then we need to create an array scope entry. Yeah, that's fine. We can figure out the memory later. How do you want to allocate this stuff and things like that. And we now say that array scope entry star entries is hash map get scope map name, and we are pushing there. So say dynamic array push star entries and entry. That's nice. Maybe we can make it static inline. And this is where we call this. So now it will be scope define internal, scope name, and scope entry. That seems good. I have to figure out what this now becomes. So if we are so now it will be scope entry type lazy, or we will do this refactoring, I guess, right now. I don't know if I should do it in the same step or not. Let's not do it. So tokens, and this will accept array token pointer tokens, and tokens will be tokens. Okay, let's see who else is unhappy. So this one is the main thing, I guess. And then we have the lookup. So the thing is, now this returns an array. Okay. If entry break, then we say that if not entry we return, then we assert that our entries we need to check that there is actually at least one entry in that array, like we expect it to be, but it doesn't hurt to assert this. And now things become tricky, because we need to completely rewrite how this thing works, right? Previously, what was happening, if it was a non-lazy thing, then we would just return the value. And if it was, if it was a lazy one, then we would do the resolution of the overloads of the functions and give that value out. Okay. And this basically is another part of the resolution. Yeah, so this function needs to change. Let's try to figure out what is the right way to go about this. I guess so. If we have more than one entry, then we are sort of expecting this to be a function. Must be a function overload. Otherwise, this should be pretty straightforward. We just say scope entry star entry is dynamic array pop of star entries. And here it will be the same as it was before, more or less, I guess. So yeah, if it is like this, then we just say that this is the result. And maybe we want to have a result like this. Scope entry type lazy. Yeah, let's do it slightly differently. So what we will do first is do the whole dance with lazy, non-lazy, and as far as the function overloads, we will do it as a second pass. Maybe that will be fine. Let's see. Let's entries and plus I. Here we can say scope entry is this, but not pop, rather get I. And if entry type is scope entry type lazy, then we do something. And what we do is we force the value. And then we replace that entry with a non-lazy one. So that actually is way more straightforward than it was before. I like it. We say star entry is scope entry scope entry. We have a type which is scope entry type value. That's correct. Value is well, value. Okay, that is force lazy entries. That's nice. And now we have the entries. And here we need to actually do the weird things that we can with the function. So there are two loops. One is about overloads on this particular level of the scope. And then there is this second one, which might not actually change, that has to do with overloads on the level of, like you can have overloads in upper scopes. We even have a test for this, I believe. So source spec C overloads Yeah, so there is the basic overload test, and I believe there is a special test for local overloads where we have a function on the top level, and then we have the same function but on a lower level, and it should still give the right answer, even in the presence of. It also checks the matching, that if we have exact matching of argument, this is the preferred match. Anyhow, getting back to here. So if we have a single value, then we just say result is dynamic array get entries 0. No, not like this. It is still an entry. We assert that the entry type is the value, and then we say result is entry value, something like that. Yeah, that should be 0. Okay, so this branch makes sense. Why are you unhappy here? You don't have a token. Okay. Hmm. Yeah, let's do it in 2 steps. So here it will actually have a pointer to the lazy function definition token. This is what we will do for now. And this is what we can pass into here. Yeah, that should not be equals equals. It's fine. Okay, so till here everything is fine, and here we can start working on this. So I is 0. Ooh. Now that I'm thinking about it, the whole setup with function overloads might need to change eventually, but maybe not right now. So let's just try to port this code as is. Oops, I didn't need to do that. We already have this stuff. So token, yeah. So previously we would force it in this loop, but now since we are doing forcing here, we would just get back a list of individual functions, and we'll need to stitch them back together. So let's get the scope entry. Let's verify that it's a value. And we also can get that value and try to do the following. We can say value star. Well, yeah, actually, this is the right way to go about it. If there is no result, then no, this is no longer lazy. If not result, then result is entry value. And this thing now needs to happen here. Actually, like this. Or maybe here. Yeah. Okay, so we go through all the entries. We verify the value. If there was no result, so this is the first one, and we just say that result is entry value, and we will check that the result is function. Then we get the overload. So this is also not necessary. This should be taken care of by the loop above. But we can say that overload is entry value. Then overload descriptor next overload is result. Result is overload. So in reality, actually no, that is correct. Okay. If not result, there should not be a way to not have result here. Here we might not have a result, but yeah, that's gonna be interesting, but not for now. Let's clean out this stuff. Okay, we'll see how terribly broken this is in a moment once we clean up all the rest. So actually this can return to how it was, where we pass in the token and we just stash that token in here. Whoop. Lazy function definition token. Isn't that how it's called? It's token. Okay. So now we just have some tests. Okay, that is fine. We can check that entries. So basically we just need to destructure the array. I think I might even have a convenience method for that. Destruct array. There is first n. So there's actually first two, but there is no first one. That's, yeah, okay, fine. Let's keep it like this. Dynamic array pop of entries. Okay, that's good. We basically need to do the same thing, I guess. Okay, let's see where we stand. Well, that was pretty nice. So looks like it's working from the first get-go. That is very good news. Let's make a commit out of that. So Ep117. And what we did is we allow multiple scope entries per name. Okay, so that was the first stage of what we were trying to do. And the second stage, getting back, is to make these things to be not about lazy function definitions, but about generally lazy stuff. And as a next step, I guess what we will do is we will only focus on the functions, but in a new format. Lazy constant expression. And this will get array token pointer lazy constant expression. Okay, lazy constant expression. This is change the type here. And instead of token force value, so what needs to happen is token rewrite constant expression. So this is what we actually need. And that actually returns a token, but should it? Maybe it should return yeah, that should just return a value, to be honest. No? Rewrite constant definition. If it's a lazy definition, no. If otherwise, it just forces it. Maybe. Okay, let's just do step by step. For now, it will return a token. That's fine. We can make it later. So we can say token star token is this thing. Okay. And actually, now we will say that token force lazy force value program token scope builder and result, all the same things. Okay, that looks fine. What are you unhappy about? Missing before. So I guess the token matcher state definition is later. Yep. Okay, that's fine. We will just bring it up in here. Okay, good. It needs to transform from token pointer to matcher state. That is easy. Token matcher state. And I assume ampersand. And we don't want the result. Okay, that looks good. Now we change this stuff where we say array token pointer tokens, and we say tokens is tokens or lazy constant expression, lazy constant expression. Okay, so for now, as this first step, we will just create an array here and see if that actually works. Yes. I'm not sure actually what's going to happen if we do that. Well, who knows? Tokens is dynamic array make of array token pointer, and then we push token value, and then we pass here tokens. Okay, so that built, but I don't have high hopes that it actually will work. Let's see. Well, I was wrong, and that is good news for us. That means we can actually commit that as well. And we are gonna say that, how should we call this? Store an array of tokens for lazy scope entry. Okay, the next step would be to take this stuff and not do it here. That's what we need to do. What we will do instead is we will just stash, yeah, all of that goes away, and here we would say RHS tokens. Okay, so it's just RHS. So technically this might work or it might not work. Let's see. Well, that is pretty cool. Just to make sure that we are doing something, because we suspiciously are passing all the tests, let's try to really break it. Okay, we really broke it, so that means that this thing actually does something and does something that we wanted to do. Moreover, since all the tests are passing actually, it is time for us to try to do this and see how that will work. Ta-da! We have it working. Great. Cool, so that was a pretty nice refactoring. There's still maybe some cleanup to do, but for the video, that would be it. Now we can now we can put these things in any order, and we can force it only at the point where we need it, which is pretty neat and should enable us to write more complicated programs. So thank you very much for watching, and hopefully see you in the next video.